So today we are factoring out the greatest common factor. Let's go ahead and throw your name on here. Always feel that. It's hard to see. Boop. Okay, so this is 6.5, and the rest of Unit 6 is going to be about factoring. So far we've combined like terms, we've multiplied, we've added and subtracted. So we add, subtract, and multiply. Which operation are we missing? Divide. So we are not going to divide polynomials because dividing polynomials is actually really hard. Because think about it, how do you divide by like x squared plus 2? How do you divide by multiple things? Instead, what we're going to be doing is called factoring. So the rest of this unit is all about factoring, and I'm going to tell you right now that this is something that's completely new. In middle school, you may have seen the adding, subtracting, multiplying. This is completely new. So you need to like turn your brains on because you will need to know how to do this for the rest of Algebra 1 and all of Algebra 2 and the state assessment and the ACT and all sorts of things like that. So this is like completely new material. Turn your brains on. So today we're going to be factoring out the GCF. The greatest common factor GCF, that's the same thing. We just write GCF because it's way easier. The GCF is the largest monomial, so meaning one term, that every term in a polynomial can be divided by. So it's the largest monomial that we can divide out. Your GCF is going to have two parts, or well, it can have up to two parts. You can have one part, you can have the other part, or you can have them both. It can have a coefficient, which is going to be a number. So the coefficient would be a number. And they can also have a variable and exponent that you can divide out. So you're going to ask yourself, what's the biggest number I can divide all of this by? And you're going to ask yourself, how many x's can everybody give me? So once we pick what our GCF is, we are then going to divide it out. We are going to divide the coefficients, and we are going to subtract the exponents. So divide the coefficients and subtract the exponents. Factoring out, so the next note here says factoring out the GCF is the exact opposite of what we did in 6.2 when we multiplied with the distributive property. So I'm going to actually grab my notebook. We can look at that. So what we're doing today is the exact opposite. You sit next to Marilyn. Grab a seat. What we're doing is the exact opposite of what we did in 6.2. So I'm going to put my 6.2 here. So remember, we went boop, 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 and we multiplied 2 times 3, and we added the exponents, and multiply the coefficients, add the exponents. We're going to divide the coefficients and subtract the exponents. So essentially, we're going to go from here to here. Instead of going from here to here, we're going to go from here to here. So it's the exact opposite. We're like undistributing. So first thing that we have to do is figure out what we're going to divide out, though. So that's probably the most challenging part about today. But once you figure it out, then you just do it. So, like I said, sometimes you're going to have a coefficient. Sometimes you're going to have a variable and exponent. Sometimes you'll have both. This first one only has a coefficient. So we've got 16x cubed plus 24. We have to ask ourselves, what is the biggest thing that we can divide both 16 and 24 by? 8. So we can divide both 16 and 24 by 8. Then we have to say, okay, I've got x cubed and no x's on that 24. So that 24 doesn't have any x's to give me. So all I can divide out here is an 8. So on the GCF line, write down 8. And the reason why we picked 8 is because it's the greatest common factor. And then we are going to write a factored form. So how you write a factored form is you put your GCF first, and then you open a set of parentheses. And then we're going to take each term and divide it by the GCF. So 16x cubed divided by 8. We do 16 divided by 8, and we get 2. And then we still have the x cubed. mask over your nose, please. And then we do the 24 divided by 8. 24 divided by 8 is 3. So we took that 8 and we divided both terms by the 8. We can then always check our problems. I never have people write down checking it. I just tell you to check it in your head. To do, what's 8 times 2? 16. X cubed, what's 8 times 3? 24. So you want to distribute it back in to check. Any questions right now? Okay, let's look at the next one. We've got 7x to the 4th plus 5x squared. Is there anything that we can divide both 7 and 5 by? No, we can divide them both by 1, but there's really no point in dividing by 1 because it doesn't change the value. So we're not going to divide by 1. So this one doesn't have a coefficient part, but it is going to have a variable and exponent part. X to the 4th means x times x times x times x, 4 of them. X squared means x times x. We can take however many the one with the least has. So since that last term just has 2, that's how many we can take. So our GCF here is x squared. The number of x's that you can divide out is always going to be the one that the last has, because it's always going to be in standard form, and so however many the one on the end has, that's how many x's you can take. Okay, so your GCF goes out in front of your parentheses, right here, and then we're going to divide it out. We're not dividing out any numbers, so the 7 and the 5 are going to stay the exact same. So the 7 stays the same. And then I've got x to the 4th, and I'm taking away x squared, and I'm going to subtract my exponent. So 4 minus 2 is 2. So I've got 7x squared plus I've got my 5x squared. I'm going to take away the x squared. So if I'm taking away both of those, there's no more x's. So it's just going to be plus 5. So we divided the coefficients on this one, and on this one we subtracted the exponents. So 4 minus 2 was 2. 2 minus 2 was 9. If we were to distribute this back out, 7, and then we would add these, which would be 7x to the 4th, and then this would come over here and be 5x squared. And we get our original problem. Any questions on when it's just x's we're dividing out? Okay, we've got 2 more then, and on these last 2, we're going to be dividing out both numbers and x's, which is this is what you're going to do on most of them. So the next one we've got, I'm going to zoom in a little bit, 21x to the 6th minus 12x to the 5th plus 15x cubed. What is the biggest and only, other than 1, number we can divide 21, 12, and 15 by? 3. Yep. So 21 divided by 3 is 7, 12 divided by 3 is 4, 15 divided by 3 is 5. So we can divide out of 3. Then, how many x's does the last guy have that he can give me? 3. So this one has 6 x's, this one has 5, this one has 3. You can only go take as many as the last one has. So our GCF here is 3x cubed. Any questions about finding the GCF? Sorry, my tables are really shaky. Okay, we're going to put the 3x cubed out in front of parentheses, and then we are going to divide the coefficients, subtract the exponents. So 21 divided by 3, I just look at it this way, 21 divided by 3 is 7. 6 minus 3 is 3. So I get 7x cubed. Then negative 12 divided by 3, so that negative stays. 12 divided by 3 is 4. X to the 5th, 5 minus 3 is 2. 4x squared. And then I do 15 divided by 3. 15 divided by 3 is 5, sorry. And then x cubed, take away x cubed. I should have no x's left. I'm never going to have any x's on my last term because my last term, I'm always going to take away as many x's as I can. Any questions about our third example? Okay. Brandon, Alex, Keelion, put your noses away, please. Last one then. 6x to the 5th minus 18x squared plus 6x. This problem, the first thing that I'm going to do is I'm going to put an imaginary 1 right here. Make this 6x to the 1st. That's going to help me out a lot. Okay. 6, 18, and 6. I can divide all of those by... I can divide them by 2. That is a common factor, but that's not the greatest common factor. 6. So if you're thinking 2 or 3, that's a common factor, but not the greatest common factor. 6 is the greatest common factor. So emphasis on that G of greatest common factor. Then we've got x to the 5th, x squared, and x to the 1st. My last one only has 1, so I can only take 1. So x to the 1st is going to be how many x's I can take. 6x to the 1st. So that's going to go out in front of my parentheses. Okay, we're going to do 6 divided by 6, which is 1. And we'll do 5 minus 1, which is 4. So we get 1x to the 4th. Then we'll do negative 18 divided by 6, which is negative 3. 2 minus 1 is 1. So 3x to the 1st. Then we'll do 6 divided by 6 is 1. X to the 1st, take away all of the x's. There should be no x's left. Okay, don't start gluing in yet. We're not done. I want to show you guys a couple things. So pay attention. Don't start zoning out yet. Okay, I want to show you guys. Any questions before I show you guys a couple things? Okay, I want to show you guys on this one. We do not have to have all of these imaginary ones in our answer. We could just have 6x here. We could also take away this 1x to the 4th and just write x to the 4th. On this, we could write minus 3x, and we don't need the 1st. This one right here, though, we do need. If you completely divide out a term and all that's left is 1, you need the 1 there, because otherwise there would be nothing there, and then it wouldn't be correct anymore. So that's the first thing I wanted to show you. The second thing I want to show you is this pattern, which will help you find your GCFs. I get to where I can see everybody. All right, so this is the pattern I want to show you. Look at how many x's are on the last one here. 0. So there's none here. X squared, x cubed, x to the 1st, x to the 1st. So however many x's are on your very last term is how many x's you'll be able to factor out. Then look at this. Right there, right there, right there, right there. Your last term on your factored form should never have any x's because you should factor them all out. So those are the two things I wanted to show you. Okay, I'm going to go ahead and stop this recording. Go ahead and glue in your notes. I will get the recording posted momentarily for those of us who came in during